Hi there, and welcome again to Module 303, Lesson 4. In this module, we will see how a spending validator works in Aiken. And in the main topic of this lesson will be the faucet validator that we saw in a previous module, the module 204, and we are going to see how it is implemented in Aiken. So before we jump into the explanation of the smart contract, it's good to see again a quick recap about these two important concepts. So the datum is an arbitrary information that it's logged in a script address UTXO, and it helps to define the conditions for spending this UTXO or unlocking this UTXO. Another important function is that the datum serves as state. So if we have an application, the datum has the purpose of providing the state of the transactions. So that is another important point about the datum. And regarding the redeemer, we can say that is a piece of data that is provided by the user that starts the transaction, and it's an interface to prove the conditions of the script. So these concepts can be result confusing at first, but a very important thing that to have present is that the datum is always related to the output and the redeemer to the input. That's the key difference between the two. So a good analogy to understand this is that if we see the UTXO as a code locker, we can see the datum as the code that we set up in the locker, and the redeemer is like the code that unlocks the locker. Here I have the smart contract overview of our faucet validator. So let's explain it part by part. So here we have the inputs. We have a UTXO log in a script address with the faucet tokens, and a datum that specifies the amount of tokens to be claimed. And second, we have a UTXO, probably in our wallet, with the access token. And we have another UTXO that serves as fee and collateral. And in this part, the part of the outputs, we have a UTXO in the faucet script address, and here we have the remaining funds. Here we have the same datum, and we have another UTXO with the faucet tokens that we took, and the access token. And lastly, we have the UTXO with some change. So in order to run this transaction, we have to satisfy 5 conditions. And these 5 conditions are: first, has the input the access token. So only the person who has the access token can claim the faucet tokens. Second, is the access token sent to the recipient of the withdrawal? Third, are the faucet tokens sent to the recipient of the withdrawal? So here, in the second and third condition, we have to send both the access token and the faucet tokens to the same output. or to the same person. 4. Are the remaining funds being set to the contract again? That is an important security issue. We want that the user send the funds again, the remaining funds again to the contract, not to somewhere else. And 5, is the new datum the same as the previous? This is another important point regarding security of our faucet validator, because we want only 50 tokens to be claimed from this validator, not less nor more. But it could be this case that a user wants to change this number. For example, let's say that a user wants to specify this number to be more than the amount that the faucet has, or an unlimited amount, and that could be a problem, right? So that way we have to ensure that the datum from the input is the same as the output. So, but it could be other cases that we want the user manage this amount or has a say about this amount, but this is not the case. But now I'm going to digress a little bit and to think of another validator that I think that explain a little bit more why the datum serves as state. A good example could be, think of a similar faucet validator like this, but the difference here is that we add a counter. And let's say that the counter is on a state of 5 here, and we specified the counter in the datum, and we add another condition that checks that each time someone do a transaction here, we want that the datum counter decrements by 1. So each time a person claims some faucet tokens, the counter is being decremented, and if the datum counter is 0, nobody can claim more tokens from this faucet. So that's another example that show why the state serves as why the datum serves as a state. Good. Now that you have a general understanding about how the faucet validator works, we can go to the PPBL Aiken starter repo, and here in the faucet.ak file we have the implementation of the faucet validator. Your task here is to understand how the implementation works, and if we go to the bottom of the file, you will see some functions that we have to. These functions are not in the standard library, but they are in the library, in the standard library of Plutus TX. So as you can see, we have to implement some functions from Plutus TX to Aiken. So, and your task here is to do the same exercise. So probably a tip is to go and check the Plutus TX documentation. You will find these functions already implemented. Probably you can see the source code. And another thing that could help you is to check the parts that you understand by going to the API documentation. So that's it. If you have if you get stuck, you can go to this Discord server and we can help you with your questions and if you have some problems. Ciao!